Hi. No, your eyes don't deceive you. That's only one page up there. One? Let's do this thing. Okay, so it says picture below is a table. That's so great because we just did some graphs, we've had some equations, so now it only makes sense we'll do some tables. Below is a table of values that show that the function f of x is first derivative and second derivative. And this, I should put that this function, each one of these f prime and f double prime, all of these are continuous. So yes, that is true, which means that we can use fundamental theorem of calculus. Whoop, whoop. Okay, so in this one we have, what is the value of this integral from -3 to 1 of f prime dx? So the way that we were doing this before is we could find the area under the curve of f prime. But I'm not seeing an f prime anywhere on here, so I can't actually do that. So the next idea that I have to do is, well, what about the fundamental theorem of calculus? Fundamental theorem of calculus says I take the antiderivative of f prime. What would that be? Just f of x. And I do f of b minus f of a. You do the top limit of integration, which is f of 1, minus the bottom. And so this is just being careful and going over to our graph. So f of 1 would be, f of 1 is -2 minus f of -3. F of -3 is 4. -2 minus 4 is -6. And you might be saying, is that it? That seems easy peasy lemon squeezy. That's right. That's it. These ones, you can see it's just variations of this, that same idea. So here, if I say -1 to 3, and it has two different functions, this is f prime and f double prime. I don't know what the antiderivative of f prime and plus f double prime is yet, but I could do each one of them separately. So this one I could say -1 to 3 of f prime of x dx plus, and then separate this integral. And really what we were doing, think about if we were doing the area under the curve, we do one part of a curve and then the other. This is just adding up different areas from different graphs. So here, I don't have the graph of f prime. So I do the next thing I probably think of, the fundamental theorem of calculus. I take the antiderivative of f prime, which would be f. And so I do f of b minus f of a. So this is f of 3 minus f of -1. I get my answer. And then over here, I'm going to do the same thing, but this says f double prime. So the antiderivative of f double prime is just f prime. F prime of 3 minus f prime of 1. Now it's just a matter of going to the table. F of 3 is 1. Actually, I'll put it down here. 1 minus f of -1 is 0 plus f prime of 3 is 3. F prime of -1 is 1. So I do 1, and then this would be 2. 1 plus 2, I get total area of this one of 3. Yay! Okay, before we start this one, I'm going to do one thing. I'm going to take this 3, and I'm going to say, you can do it at the end. So just like a coefficient of derivative, you can kind of take it for a ride, like you can multiply it at the end instead of multiplying it the whole way through. We can do this here too. We can take the 3 out front. Then if we focus on just this part. Okay, so find this value. What would you have to do? The antiderivative of f double prime would be f prime. Remembering we're doing f of b minus f of a, so f prime of 5 minus f prime of 1. You're going to multiply whatever you get times 3. So I'm going to take 3 times f prime of 5 will be 2. F prime of 1 is 0. 3 times 2 is. Okay, and now we've got to like pull out the big guns. Do you see this? That all looks messed together. But we can separate it. We can we can figure this out. We've got 1/2 that I'm bringing out in front, but only of this first integral. I'm going to integrate from -3 to +3 of f prime of x dx. This one, there's a 2 in front, but I've still got this integral from -3 to 3 of f double prime of x dx. Okay, you write the steps below it. So I'm going to write 1/2 times something plus 2 times something. What goes in each of those somethings? Okay, well, the antiderivative of f prime would be f of x, and we always do f of b minus f of a. The antiderivative of f double prime would be f prime. And now substituting in. So go up to the chart, make sure you can do that part, and then join me for the answer. f of 3, got 1 minus 4. Prime of 3. That was minus -2. -3/10 plus, or 2 plus, there we go. What did you get? I got -3/2 plus 10, which would be 20/2. If I add those together, I get 17/2. Okay, so that's the fundamental theorem of calculus put into play with the table. Now I get to answer some other questions about this. It says, what is the equation of the tangent line of the graph of f of x at x equals 3? Oh, it's been so long, a tangent line. It's like coming back to see an old friend. This is at x equals 3. There's 2 things that I need for a tangent line. What are they? A slope, which would be f prime of 3, and a point, which would be f of 3. This has nothing to do with the fundamental theorem of calculus, but I do want to remind you that all the old stuff still applies. We can't forget about any of that. F prime of 3 would be 3. F of 3 is 1. My chair is so squeaky. If I do y minus y1 is equal to m, because it's from here, this is the slope of the tangent, x minus x1. Next question says, use the equation of the tangent line to approximate the value of f of 3.1. So sometimes this is called a tangent line approximation. Sometimes this is a locally linear approximation. But what I do is once I get my equation of my tangent line at x equals 3, now I can substitute in 3.1. Simplify, so I've got 3.1 minus 3 is just 0.1. Oops. This would be 0.3, and then I would have plus 1, which is 1.3. So f of 3.1 is approximately 1.3. Okay, this next question is pretty important though, because this one's asking, is this an over or under approximation? And I feel like this is like putting our hands together with lots of things that I've learned so far, that you've learned. So at x equals 3, let's think about what this graph looks like. The graph of f of x. At x equals 3, I know f of 3 is 1, so I know the point where that one is. But I also know that I've got this increasing, so at 3, I know the function is increasing. And I also know that the f double prime is negative. So f prime is positive, so I know f is increasing. What does f double prime being negative mean? This will mean concave down. So if I make a function like that, where f of x is increasing and concave down, and actually the increasing and decreasing doesn't really matter, the concavity does, but I can see concave down. It looks like it's part of a frown. Draw a tangent line on that. Make a point somewhere. Is this tangent line, except for the point of tangency, over or under the function f of x. It's literally above it. It's an over approximation. So I'm going to say this is an over approximation. Is an over approximation, and my reason, giving my reason for an answer is because f double prime of 3 is, what did we say this one was? Is less than 0. And I can see, therefore, f is concave down. That's enough information, and the picture really helps. Okay, thanks so much. You did great. Bye.